this lesson will focus on the financial math section of the math syllabus. So first and foremost, you need to be familiar with these four formulas shown here. The first formula is simple interest, where A is your amount that you have at the end of the period, and P is the amount that is put in at the beginning of the period. 1 plus I, your interest rate, times N, the number of periods. So simple interest is done using this formula. Simple depreciation, which is a decrease in the value of money or the value of an asset, is done using this formula. Remember that this is a minus because your value is getting smaller, your value is depreciating. Then compound interest is done using this formula. Remember that your number of periods is an exponent on your brackets and not multiplied by your n, where A and P have the same meaning as above. And compound depreciation is the same formula, however this is now a minus because your value is depreciating and getting smaller. So in most financial formulas, R is your interest rate, so that'll be quoted as a percentage, as in 8% or 10% or 13% per period. I is your investment interest per period. So say it's 8% per annum, and now you want a monthly interest rate. You would then calculate, you would convert your effective to nominal, and I would then be divided by your number of periods. N is your number of periods in total. P is your principal amount, the amount that you're putting in, and A is the amount at the end of the period. So for example, 100 Rand invested at 8% compounded monthly for 1 year. So the amount at the end equals the amount you put in multiplied by this bracket. So the amount at the end equals 100, that's the amount you put in. 1 plus 8%, that's quoted here, over 100 because it's a percentage, so 8 over 100, divided by 12 because it is monthly and there are 12 months in 1 year. 12 being your number of periods because there are 12 periods in a year. The periods are your months, so there are 12 months in a year. That is why your exponent is 12. And your amount at the end of the period would therefore be 108 Rand 30 cents. It's important to remember that hire purchase is always simple interest. So you will always use the simple interest formula when you do a hire purchase calculation. Next, we move on to timelines, which are more complicated financial math questions. So it's easiest to draw your timeline as shown over here. Your money in must be positive. So as shown here, I've drawn it above, it's positive. Your money out must be below the timeline, indicating that it is a negative amount. Money going forward has a positive exponent. So your exponent on your bracket in compounding would be positive, and when you're taking money backwards, it will be negative. So take this, for example, a loan of 18,000 over a year at 12% per annum compounded monthly, repay it as follows, and you are given these repayments, which have been drawn in on the timeline. So what is the final payment? So we take this X, we're going to treat 18,000 as money going in because it's been given to you, and now you have to pay off that amount, so we treat that as money coming out, or money coming off your liability that you owe, which is indicated by the negatives here. So in order to deal with money, you have to take it to one point on a timeline in order to compare it. You can't compare different values at different times. So it's easiest now to take it to this point. So we'd say X equals this amount with a positive exponent for the number, so 12 months, minus all of these amounts with positive exponents for the amount of time that they need to get to the same point as X. So in this case, it's 10, 7, and 4. And you would then solve for X, and X comes out to be 4,557 Rand 43 cents. Next, often you have to convert from effective to nominal and from nominal to effective. So effective is simply where your compounding period matches your interest period, and nominal is where your compounding period does not match your interest period. So for example, you have to convert 8% per annum compounded quarterly to compounded monthly. So now the easiest way to do this is to take the bracket that you would use in your compound formula. Now you need to make sure that both sides are for a period of 1 year. So there are 4 quarters in 1 year and 12 months in 1 year. Then you know they've given you 8%, so you go 1 plus 8 over 100 being 8%, divided by 4 because there are 4 quarters in a year, to the power of 4, equals 1 plus r, you are looking for this rate, over 100, divided by 12, there are 12 months in a year, to the power of 12. You solve this. Just remember at this step you minus 1 first because it's a reverse of your operations. You must minus 1 first before you times by 12, and you'll get 7.95% compounded monthly. In the same way, if you had to do it the other way, you'd use the same layout, simply you'd be solving for an r here and you would have 7.95 over here. Next, we move on to future annuities. So this is where you put money in to gain in the future. So it's a sum of regular payments with interest. This is the formula where this is the future value, this is your payment per month, your interest, and your number of payments over your I. This will be given to you on a formula sheet. You must just remember that there are 3 scenarios. If they say to you, we put money into an account every month, starting at the end of this month, you will follow the normal formula. You are over here, and at the end of the month, you put in money. So if you're putting in at the end of every month, you follow the normal formula. Simply use this. If, however, they say we deposit money immediately, so right now we deposit money and we deposit at the beginning of every month. So for the last month, it sits for a whole month with no deposit at the end. We would simply use this formula and multiply in, so multiply over here, 1 month of interest on all of the amounts. So you would use this formula, get a number, and then multiply that by 1 month of interest. If you have a case where they say we pay in at the beginning of every month, and then we also make a last payment at the end of the last month, you will simply use this formula with n being n plus 1. So say it was for a year, you would then go, n would be 12, but now we're paying now, and we're paying at the end of the last month, so it would be 13 because it's n plus 1. That's just something to look out for because they can be quite sneaky with that. But that's probably as complicated as it will get. Then we move on to present value annuities, which is a loan with regular repayments. So they've given you money and you have to pay it back in monthly installments. This would be your installments, your interest, and remember a negative exponent for your number of periods. So here's an example where, so that's your present value. Now where you have a loan and you have an outstanding balance on that loan, you may be asked to calculate your outstanding balance. You must then bring back the present annuity to the end of the period you're trying to find. So say, as said here, a loan of 36,803 is paid off in amounts of 2,000 Rand quarterly. The loan is taken for 10 years. Calculate the outstanding balance after 9 years. Interest rate of 10% compounded quarterly. So your outstanding balance, so you've taken it for 10 years and you want to know after 9 years how much is left. So your outstanding balance would be your payments. So it's the same formula as your present value, except you would go 1 minus your I divided by your 4 because there are 4 quarters in a year to the negative 4, simply because the full term would be 10 years. Now you want to bring it back to 9 years. So you need to bring it back by 4 quarters. So you would then go negative 4. If you wanted to bring it back to check your outstanding balance at 8 years, you would go negative 8 because you want to go from 10 to 8 years, which is 8 quarters. So you would go negative 8. And that will give you your outstanding balance on the loan that you have taken. Lastly, we move on to sinking funds, which is often asked in the financial math section. They'll often say a company has set up a sinking fund and give you a whole lot of different scenarios and amounts. You need to follow these 4 steps. You need to find the scrap value of the item, which is often given to you. Find the cost of a new item. They'll often tell you in 4 years it will cost this, or they will say inflation is at this rate, calculate how much it will cost in 4 years. Then you must find the amount required in a sinking fund in order to cover the cost of a new item. Remember to take off the scrap value, because you will be paid that and use that to pay for your new item. So in the sinking fund, you must take off the value of the scrap value, and then you must calculate monthly repayments into a sinking fund to get the amount that you require in the sinking fund. These questions are quite nice. As long as you follow these steps, you should be well on your way. They are often quite nicely scaffolded, so they will ask in questions, in sections, and then they'll kind of lead you into how to do the sinking fund. But it is always nice to know these steps and how to calculate each value that you need.